Welcome to Intro to SAS, the Shared Access Signature. I'm Charles Barnett, PM with Azure Storage. Today we will be covering the concept of SAS, as this beginning video will serve as the foundation for SAS usage in blob storage. It will be complemented by several other videos that will build on this foundation. So, without further ado, let's get started discussing SAS and how it can be leveraged to protect and share your data stored in Azure Blob Storage. In this training, we will cover a multitude of SAS-related topics ranging from the concept of SAS, different types of SAS, use cases for SAS, and best practices to use with SAS going forward. Again, we are putting the foundation in place so that SAS can work for you and your data protection needs. In future videos in the series, we will discuss implementations of the different SAS types using various tools that are available. It is important that you have a full understanding of the concepts presented in this video in order to move on in the series and get SAS working for you and your team. As you review the deck, please note that references will be provided at the conclusion in order to allow you to seek out and deep dive any topic. All information shared is covered in the official Microsoft documentation. This brings us to the question of the day. What is the shared access signature? A SAS has two parts. The URI of the storage resource, with the second part, the SAS token that is created on the client side, appended to it. This token has a signature, which is used to authenticate the client to the resource. Another pressing question is, what does a SAS define? A SAS defines which resources a user may access, whether it's a blob, queue, or table storage. Depending on the type, it also defines whether the user can make changes or requests at the account level, service level, or individual blob level. We will explore this topic later. Another permission that the SAS defines is the time that the user has to access the resources. This can be achieved in most cases using the start time and expiry time parameters. Lastly, a SAS defines the permissions granted to the user, such as read, write, or delete. These permissions can range from setting the metadata on the account to granular permissions specific to a blob, depending on the SAS type. A SAS can take two forms, either an ad hoc SAS or a service SAS with a stored access policy. In the ad hoc form, the start time, expiry time, and permissions are included on the query string of the SAS URI. As the naming implies, service SAS with stored access policy is for a service SAS only. For a service SAS with the stored access policy, the policy is defined on the resource container. This policy can be used to manage one or more shared access signatures. When the service SAS is associated with the stored access policy, the SAS inherits the constraints of the policy, which are the start time, expiry time, and permissions. The benefit of using the stored access policy is you can revoke the privileges of users using the service SAS with the stored access policy without having to regenerate the account keys. To revoke SAS URIs created ad hoc, you would have to regenerate the account keys, which can be a headache due to other SAS URIs and applications or clients that may be dependent on signing with that key. The two forms, ad hoc and service SAS with stored access policy, are not to be confused with the three different types of SAS, which we will now take a look at. So for the three types of SAS, there are the account level SAS, the service level SAS, and the user delegation SAS. The main differences between the three are the authorization methods and the types of resources that can be accessed by them individually. The account level SAS provides access to one or more services in the account, meaning you can access blob storage, table storage, and queue storage with the same SAS. It has the ad hoc form with the start, expiry, and permissions included on the URI. It can also grant access to service level operations that aren't available with the service SAS, such as get operations at the service level. It's authorized with the account key. If this SAS is leaked or stolen, the account key for which it is assigned will have to be regenerated. Next, we have the service level SAS, which provides access to only one resource in the account. For example, if you have a blob storage secured with the service level SAS, you cannot have file storage secured with the same SAS. This type of SAS can also be ad hoc form with the necessary permissions and start expiry times on the URI. But, as we previously discussed, a service SAS is the only type of SAS that can optionally have a stored access policy associated with it. For more information on stored access policies, please review the references section of this training, where the link to the official Microsoft documentation will be provided. This type of SAS is authorized with the account key. Last but not least, we have the third SAS type, the user delegation SAS. What makes this SAS special is that it can be secured by Azure Active Directory through generating the user delegation key. This makes it the most secure of all SAS types. Another unique feature to this SAS as it is applied to the blob only. It cannot secure your account or services in your account. Like the other two types, though, it is ad hoc form with permissions and relevant start expiry on the URI or token that is generated by the client. Again, links will be provided at the end of the presentation deck for you to dive deeper into these topics if you prefer. So, to recap what we learned about all three SAS types, the user delegation SAS is authorized by Azure Active Directory and signed with the user delegation key. This SAS has the ad hoc form. The account SAS is authorized by the shared key and is signed with the account key. This SAS also has the ad hoc form. The service SAS is authorized by the shared key as well and is signed with the account key. This type of SAS can be associated with the stored access policy to allow it to have the form of service SAS with stored access policy. But remember, this SAS can be ad hoc as well. The format of a SAS URI is a storage container URI with the SAS token appended on the query string. The token will always begin with the question mark, followed by Hypertext Transfer Protocol Secure, otherwise known as HTTPS, to encrypt the data to increase the security of the data transfer. The signature parameter of the SAS token is used to authenticate with the storage service when the request is made. Now, let's take a look at some of the common parameters passed as part of the SAS token. Taking a look at the table below, we can see the field name, the string that is passed as the param on the token, whether or not the parameter is optional or required, and the example values for each parameter. Now, these are just some examples to get you interested in the SAS token. To see all of the other parameters and the values for each of those, please head over to the Microsoft documentation. Links to the correct documentation will be provided in the references section of this video. Now, let's take an in-depth look at the composition of this SAS URI. Here we have a complete SAS URI with a string of X's acting as placeholders for the signature value. Again, this follows the format of the storage container URI with the token appended to the end of it. We can see here that the token starts where the question mark is found. Here we have the first section of the storage resource URI, which is the account name .blob.windows.net. Again, for it to be the most secure, we've used the Hypertext Transfer Protocol Secure, and this first section of the string represents the account name. The second subsection, following the /, is the name of our container. Here we have named the container sample container. In the case of blob storage, the second part following the / is the container name. The third subsection will be the blob name. If you're using SAS with a different resource like files or queues, this part of the URI will not be a blob name, of course. For our purposes of getting started with blob storage, though, this will always be the name of the blob that we are attempting to access with the SAS URI. The three parts that we just covered are the three components that make up the storage resource URI. The complete storage resource URI, which we have now covered, is highlighted in blue. Now let's take a look at our token, which begins with the question mark, which to those of you that are familiar with web development also denotes the beginning of our query string. Our first parameter, SV, holds the value of the current storage version that is being used. In our example, the second parameter of the token is signed services, which lets us know that our example SAS URI is an account SAS because signed services is an account SAS parameter. This parameter specifies the signed services that can be accessed with the account SAS. In this case, the value BFQT, which represents blobs, files, queues, and tables, meaning that this SAS URI can be used to access or modify any of those resources that belong to this account. Notice that the first parameter of the token, the storage version, was preceded by the question mark, signaling the start of the token. All remaining parameters, including the signed services parameter, will be included using the ampersand character. The third parameter of this account SAS URI represents the signed resource types. The value here, SCO, signifies that this SAS can access service level APIs, container level APIs, and object level APIs. Examples of service level APIs are get set service properties, get service stats, or possibly list containers. Likewise, examples of container level APIs are create container, delete container, or list blobs. Object level APIs let you work directly with blobs. A couple of examples of object level APIs are put blob and delete blob. The next parameter, SP, represents the signed permission that the SAS has on the account. In our example, we will break down the string value contained in the SP parameter. R equals read, W equals write, D equals delete, L equals list, A equals add. Keep in mind that this does not apply to blobs, but can be found on this account SAS. C equals create, U equals update, which is for tables and queues only. P equals process, which is valid for queues only. I is for set immutability policy, which is blob only. T is for tag, again blob only, U is for setting blob index tags, and F is for filter, again only for blob, which allows filtering by blob tags. Our final value, X, equals delete version, which applies to both the container and the blob. We'll look at the next parameters together, as they're the start time and expiry time of the SAS token. The datetime format must be expressed in one of the accepted ISO 8601 UTC formats. This is a key element to make note of when looking at both the start and expiry times. Our last parameter is the signature. This is the part of the URI that's used to authorize the request that's made with the SAS. It's a unique string that's constructed from the fields that must be verified to authorize the request. In our example, we've simply included a string of X's to mock the value of the signature, but in real life, your signature will be full of actual characters that have meaning. To quote the docs, the signature is a hash-based message authentication code that's computed over the string to sign and key by using the SHA-256 algorithm, and then encoded by using base64 encoding. Taking a look back again at our initial SAS URI, we can see that we've examined the SAS token that begins with the question mark and has multiple ampersand symbols to include various parameters. The entire string in blue represents our SAS token. We have now examined all parts of the SAS URI. As we stated earlier, different parameters are available for different resource types. So, depending on the service and type of SAS, your SAS values are going to vary. Again, please visit the documentation at the end of this session to dig in deeper and possibly find other parameters that are beneficial to your use case. What are some of the use cases for each SAS? Starting with the user delegation SAS, with this SAS, there's no need to store the account key with the application code. This extra layer of security means that when you want the most secure SAS, you will use the user delegation SAS. Also, when you want the ability to revoke the SAS without regenerating your account key, the user delegation SAS will still be the choice. Do remember though, that it does only apply to blob storage, allowing access to containers and blobs. Next, the account SAS can be used to delegate access to multiple services in the same account. The same service could be used for both files and blobs, for example. Other use cases include when the SAS needs access to blob service level operations like get set blob service properties, get blob service stats, and get account information, just to name a few. For the service SAS, as we previously discussed, This is the only option when you want to associate the SAS with a stored access policy. So we wouldn't want to forget that use case here. Also, this SAS is useful when you want to limit the SAS to only having access to one service in the storage account. Now we'll take a look at some common risk of using a SAS, with the first being the dreaded scenario of the SAS being leaked or exposed. This can be a terrifying scenario for multiple reasons. For one, the reason we're using a SAS with the account is to protect the data. If the SAS is leaked, the data is no longer protected, and unauthorized parties will have access to the data to share it with others that don't have access as well. Also, with unauthorized access to the data, these same malicious actors can make changes to the data and corrupt it, destroying any integrity that the data has. The only possible solution in this instance is regenerating the account keys, unless you have employed the user delegation SAS, as we talked about earlier. The second risk that we will cover is the scenario where the SAS expires in a client application. This is a major headache for the guardians of the data, as now the application will be useless without access to the data that drives the usage of the application. To circumvent this from happening, it's best to stay on top of expiry dates related to the SAS and renew the SAS before this happens. We would suggest that you have the application to auto-renew the SAS, but if for some reason that isn't possible, manual renewal will also work. Again, when including a SAS as part of your application workflow and security, always be mindful of the expiry date. Now let's take a look at some best practices to keep in mind as you use the SAS. As I mentioned several times throughout the session, the user delegation SAS is by far and away most secure type of SAS with its extra layer of security. Whenever it's possible, use the user delegation SAS. Always use HTTPS. This goes without saying. Here, as in any other type of web scenario, it's no different here. In the case that the SAS expires or a user's privileges on the SAS need to be revoked, always have a revocation plan in place. Using a near-term expiration time on an ad hoc SAS will ensure that a SAS is valid only for a short time in the event that it's compromised. Defining stored access policies is best for several reasons. For one, the permissions and start expiry times do not need to be included in the URL. Also, if the SAS needs to be revoked, you can do so without having to regenerate the account key. Regarding SAS auto renewal, clients should renew their SAS well before the expiration time to allow for retries by whatever service is providing the SAS if it's unavailable on the initial call to that service. If there's a client that's making regular routine uses of the SAS, avoiding the expiration will be crucial here. Also, regarding SAS start times, intermittent failures can occur due to clock skew. When setting the start time, make it at least 15 minutes prior to the time it will be first used. Or do not set a start time at all, making it immediately available. Be careful with the SAS datetime format. If a number is omitted or added, the request will be rejected. Also, for certain utilities, such as AZ copy, a format must be used that specifically includes seconds. Please refer to the docs for clarity if there is a question about the datetime format of your SAS. Be specific with the resource that's going to be accessed by your SAS. Always use the principle of least privilege, only granting access to resources that will be accessed or modified, and not all resources in the account. Remember that, always use least privilege. Lastly, use AZ Monitor and storage logs to view spikes and authorization failures and to gather data about your failures. As promised, here are the links to the Microsoft Docs. Feel free to give them a look in order to deep dive any area that you may want to learn more about. Feel free to copy the links in the references section. All the info presented in this episode can be found at these links. We want to thank you for tuning in and thank you for choosing Azure Blob Storage. Be sure to check back in to catch the complimentary videos detailing how to implement the different SAS types that we just discussed. See you soon.